So today we will discuss about a topic regarding quantum mechanics, the quantization of a particle inside a one-dimensional box. This is a one-dimensional box and this is the particle moving back and forth inside the box of length L. Suppose a particle is constrained in one-dimensional box of length L. The walls of the box are infinitely hard so that the particle does not lose energy each time it strikes the wall. These are the walls. So according to the de Broglie, a particle trapped inside a box is just like a standing wave in a string stretched between the walls of the box. In analogy, the wave variable psi for a moving particle must be 0 at the wall. At this position, x is equal to 0, here x is equal to L. So at this position and this position, the wave function must be 0. The possible wavelength of particle are determined by the length L of the box. Treating the wall as nodes, the largest wavelength is given by, so these are the possible state of a particle. Here the L is equal to lambda by 2. Here lambda denotes the wavelength and lambda is equal to 2L for this state. For psi 2, like L is equal to lambda, and for psi 3 state L is equal to 3 lambda by 2. So lambda is equal to 2L by 3. So if we see the trend of lambda, generally we can write for n, lambda n is equal to 2L divided by n. Here n is equal to 1, 2, 3 and so on. According to de Broglie wavelength, lambda is equal to h by p. Here h denotes the Planck's constant and p is equal to root over of 2m e. M is the mass and E is the energy. So from this equation we will get the value of energy equal to h square divided by 2m lambda square. And before we see that the general value of wavelength is 2L by n. If we put this value in this equation, we will get the general equation of energy. En is equal to n square h square divided by 8m L square. The value of n are n is equal to 1, 2, 3 and so on. So this shows that the energy of a trapped particle is quantized and each permitted energy is called an energy level. The integer n specifying the energy level is called the quantum number. Thus the energy level of a trapped particle are always discrete or quantized. One thing is the value of n cannot be 0. If we put the value of n is equal to 0, then the value of wavelength will be infinite, which is impossible because the particle must have a certain finite region. So from this we can see that the energy of a particle inside a one-dimensional box is quantized, and this is the whole solution.